Joining me today is Scott Lewit and Joni Richards of Structural Composites, company that has spent decades advancing composites across defense, marine, and transportation. We're going to be discussing some recent news. They were recently awarded a contract valued at more than $9 million by the U.S. Army Corps of Engineers for the Canaveral FRP sector gate project, and we'll be showcasing that here in a second. But welcome both of you. Scott, I know you've been on the podcast before, but I'm really glad that both you and Joni could join me on the podcast today.
Yeah, thanks, Jonathan. We're on a lot of really exciting things happening for us over the last few years, and some of it's been decades of foundational work, but at this stage, seeing a lot of these threads come together into projects that are really meaningful. We're pretty excited to be able to share with you some exciting news.
So, yeah, before we get into the topic, why don't you give us, for our listeners who may not be familiar, give us a little background and a little history on the company itself.
Yeah, sure. So, I'm Scott Lewit, one of the founders of Structural Composites, and we formed in 1987. We're a spinoff of the Florida Institute of Technology. And I met my partner, Dr. Ron Reichard, was my college professor back before we formed the company. Back in 1982, we met. And after I graduated with my master's degree, went to work up in the defense industry, and not in the military, but as a defense contractor, and got to work with the SEAL teams and the underwater vehicles.
Nice.
And I was able to bring a contract back to the university to work on the manned underwater SEAL delivery vehicles.
Yeah.
And that started the company back in 87, and a lot of people were going into aerospace. We were marine. In the 90s, we invented a product line called Prisma Preforms, and that took the wood out of boats. We were taking half the weight out of boat hulls and taking all the labor, about 80% of the labor out of boat construction. Really redefining how shops were laid out, eliminating the whole stringer station, framing stations out of fabrications. And then in 2009, we had, we've been working SBIR, and Joni will talk more about the SBIR program. She came out of that program from NASA, but the Small Business Innovative Research Program's kind of been with us all along, helping us get money for research and development. The marine industry doesn't have the kind of budgets that the aerospace industry has. So we kind of learned a trick of using the Navy and the other branches of government to develop research. And, and it's great to develop research for the military, develop products for the military. But, even for the military, they don't make a lot of things. So their volumes are low. Yeah. And so we kind of developed a method of engaging the commercial markets early with our Navy work, which then makes the products commercially available. And we found that works good. That benefits the military and the commercial market.
Yeah, Joni, if you would just share a little bit background on yourself, the company.
Sure. So I joined Scott's company in about 2022. Prior to that, I was with NASA for 35 years. I got my degree in electrical engineering out of UCF and went straight to Kennedy Space Center. Did half of my career working with in the shuttle program, and then I actually worked with the crew. I was a payload engineer.
Wow.
So when experiments would be delivered to Kennedy Space Center, I would write all the problem reports and check out procedures. And so that was a great chapter of my career. But then I went up to NASA headquarters in DC for a year, and they told me that was my time to play around in the sandbox, look around. And I stumbled into technology transfer, and I was like, what's technology transfer? So I really learned quite a bit of what technology transfer was, including the Small Business Innovation Program, research program. So when I came back to Kennedy Space Center, I ran that program for about 9 to 10 years. And it was a great opportunity to work with the small businesses. So we would put out solicitations, problem statements, all the NASA centers would, and then we would work with these small businesses to come up with technologies that we'd either utilize, or we'd even look at phase 2, which is around $1.5 million. And then the ideal situation is phase 3 opportunities. And that's one of the things that Scott and I have been going up to Washington, D.C. and actually had some of the language that was placed in the reauthorization bill. One of the things that's kind of a, point that I'm trying to make sure is all the agencies understand how to utilize phase 3 contracts, because once you get a phase 1 and or go on to a phase 2 contract, it makes you eligible for sole source contracts. And a lot of the acquisition groups don't know how to utilize those contracting.
They don't make it to phase 1, right? I mean,
well, again, the government agencies are, if they're not familiar on how to utilize that contracting mechanism, that's one of the things that we really want to push hard on.
Sure.
Because if they don't know how to utilize it, they want to go through the whole cycle of a normal contract cycle. So that's one of the sweet spots for me, to try to make sure that that gets well understood, and that the staffers and the folks that we meet with up in DC understand that there needs to be more training given to these contracting specialists and officers, how to utilize the contracting mechanism. But so I retired from NASA in 2021 and had met Scott prior to that. We had an event here that he had a composite application summit with a lot of his OEMs and some of the support contractors. And so he heard that I was contemplating retiring. So after about a year in retirement, I came out of retirement, and I'm actually the certified project manager on the Army Corps project that we just won late last year.
Awesome. Well, that's a nice segue. So why don't we talk about that? A $9 million contract with the Army Corps of Engineers. Let's talk about this Canaveral sector gate project. Give us a little overview, and I've got some follow-up questions there.
Sure. Yeah, sure. So this one's close to home for us. So located maybe about 15 miles from where we're sitting right now. The lock here at Port Canaveral is a pretty important lock. It supports the space industry. A lot of equipment coming through it, and the seaward gate that you see in the picture here was built in the 60s. And like a lot of our waterway structures, they're really aged out and need of repair. So quite a bit of our waterway structures are in need of this. And there was a group within the Army Corps that really several years ago started seeing the opportunity for composites, and started pushing hard to get composites to be looked at even by the Army Corps. And they were successful at creating some regulatory language that required projects to go through a life cycle cost analysis to look at composites.
Sure.
And that really helped a lot. And so actually, we're one of 3 awarded composite projects that the Army Corps has made. They're awarded to 3 different companies. And they're all tracking a very similar story, which is really good for composites. So we found the sweet spot for us. So in the case of the Canaveral sector gates, they're currently made out of steel, and they weigh about 180,000 pounds each side of the gate. Right. And in composites, they're going to be a good bit lighter. Although that's not the big driver, because weight is not the problem. It's really corrosion.
Yeah.
So the life cycle cost analysis showed about a 500% life cycle cost savings over the 100-year design life, which is pretty profound. They saw that across the other projects too. Now that all 3 projects are bid and in operation, they're also seeing something else. We're about 30% lower in acquisition cost.
Wow.
We're 30% lower in acquisition.
30% lower.
Yeah. So
explain that. Unpack that if you would.
The steel gates are not inexpensive, and we found this in the rail project we did with CAG and Trinity Rail, is that when you have a lot of pieces of metal and you're doing a lot of labor and putting them together, thousands of pieces, that drives up the cost. And then here you have a lot of components have to be welded, a lot of shapes that are hard to do, and then all of the corrosion mitigation they're going to spend on it during just that acquisition phase. It turns out that we're less expensive. So there's actually 3 benefits that we're seeing. So we've got an acquisition cost savings, we've got the life cycle cost savings, and then the The other one's pretty interesting too. Is there are bids for these type of gates out there, and they're delivering steel gates. It's taken them about 4 to 5 years to deliver. We're doing it in 2.
Wow. 2.
So we've got so what a beautiful spot to be in, right? So we've got the acquisition cost savings, we've got the life cycle cost savings,
Yeah.
right? And we're going to deliver at twice the speed. And and what's letting us do this over here at Structural Composites is it's not that we're inventing it, we're leveraging millions of dollars of investment that's been made.
Sure.
By the Navy, into our Prisma technology, into our CoCure, by Wabash, by Trinity Rail, the supply chains that help build all this and scale it up for us. And so we're coming in with some pretty mature technology, and it's letting us make a nice impact. And now we can, kind of map it out. And in fact, Army Corps has some roadmaps that kind of show you where they want to go. Our next challenge is getting those funded, right?
Yeah.
Because even though the need's there, everybody's fighting for the same monies.
Of course.
And getting these things funded is really, really important. The St. Lucie gates are kind of next on the sector gate side of things after this one. So to give you a feel, we'll be delivering these sector gates before December 15th of 2027.
Okay.
Right to the port.
All
right.
Year and a half away, huh?
Yeah. Our approach is a little different. We're not going to make a massive sector gate and ship it down the road. All right. So we've really are thinking hard about waterway structures. And what we're trying to do is not really just make a sector gate structure. We're trying to make a waterway technology. And part of that is making components so we can ship everything over the road.
Sure.
All right. And so in this case, everything's going to be able to go onto flatbed trucks. We have an assembly site about 3 miles from the actual lock. And
wow.
Yeah, we're going to assemble these on site.
Right.
And Jonathan, through another program, I don't know if we talked to you about, but through an Air Force project that we're working with to make the C-130 a float plane, we got introduced to a whole new field called synthetic engineering, and it's using gaming engines and physics-based simulation to do stuff before you actually do it. And we met this team on the Air Force project, and been using them on a couple projects. So before we actually assemble these sector gates, the site where we're going to do it is going to be scanned into full dimensional scans. It's going to be brought into Unreal 5 gaming engine, all the equipment scanned, and we'll be able to do the assembly in a simulator before we go out to the site, because we've got some very tight dimensional tolerances here. So
is this using any kind of AI? Is this AI type software, or is it?
Yeah, I would say AI is underlying a lot of this now, and it's making it move a lot faster.
Sure.
And it's helping develop things quicker. I don't know that it's not like AI is doing the design, but it's certainly a tool to help us,
Yeah, it facilitates.
Yeah.
In my understanding, this is the largest FRP structure ever deployed by the U.S. Army Corps.
It'll be America's largest waterway structure, is what we understand.
Wow.
Yeah, and so it's important, and no pressure, Joni.
Oh, Joni, you were going to say?
I was just going to say, add on to what Scott's mentioning too, is that we're trying to design this so that it's not custom built, that we can apply it to other structures. So that's something we're keeping in mind as
proof
the
concept
design matures.
What specific technologies that are coming out of the SBIR programs that help make this project possible? Any specific technologies from these programs?
Absolutely. Yeah, sure. So our Navy work really helped us advance the Prisma technology.
Yep.
And kind of how the SBIR program works too, right? So your phase 1 and your phase 2 funding is the Small Business Administration's pots of money that they've collected from the agencies. Phase 3 is your success. It's anybody's money that's not the SBA money. Okay. And so we took technology from boats, brought it into transportation rail, all that contributed the commercialization of that.
Sure.
So getting Prisma scaled up, CoCure scaled up. These will be new materials for the waterway structures. They've been in boats since the mid '90s, but for the Army Corps, these are new materials. The Army's seen it before, the Navy's seen it before.
Right.
So we have a lot of use. But those foundations, and on top of the composite bridge that we did with the Composites Institute 4 years ago. So we installed the first composite bridge in Tennessee 4 years ago.
I remember that. We talked about that with the IACME meeting, I believe.
IACME, it's got the fiber optic sensors, right?
Yeah, right.
In there. And so they're all little foundational pieces that help you build that confidence to be able to move to something of this scale. You see what I mean? And, some of the things we're trying to do on this is, we weren't funded to put the fiber optics in here, but we're trying to find that, for example.
Right.
Because we're like, gee, wouldn't it be silly not to do it if we can?
Yeah.
Right. And so there's actually a lot of interesting spin-offs that we're getting from this project. And we have another Navy project that we're working on that we're just finishing a phase 1 on detection of unmanned underwater vehicles. And some of that sensor technology actually looks like it might have application here in the waterway structure for manatee protection. So we're actually talking to them. And so it's, I think, one of the very unique things that Joni did at NASA that we're doing, everybody kind of stays in their silo, in their industry and their silo. By the nature of this kind of pervasive technology we developed, we're out in all these different markets and silos, and we're able to grab things that we see. The Air Force invested millions on that synthetic engineering. We stole it. Sure. Okay, the Navy did this. The Army Corps is doing this. And all these guys are in their bubbles, but they're not cross-communicating. And we have that advantage of being able to cross over and leverage these things. And, we don't have to invent it to be a big help, right? And so, it's a great leveraging effect. And we're trying to encourage that more and more within Department of Defense, right? As we talk to the SBIR program, there's a lot of technology in this country. There's thousands of companies performing phase 1, phase 2 SBIRs with transformative technology that are frustrated that they can't get to that phase 3 funding. Yeah. Okay. And it's American technology that we need. And so, we're working really hard on that. And maybe just to pivot a little bit into the SBIR as it relates, because, this is a phase 3 SBIR for us. Right. On Navy work. Okay. So the SBIR did not get reorganized in October, and it actually lapsed. So for those,
why is that?
Well, look at where we are with government now. So there's a lot of cutting back about everything, especially the budget. Yeah. And there's legitimate parts to it, of course, right? And part of that was some companies really look at the SBIR program, the phase 1, phase 2 program, as a funding stream, not as a technology funding stream.
I see. Yeah.
Okay. And I think that's a mistake, right? And so you'll see companies have gotten really good at writing proposals, and they'll put in hundreds each solicitation. Yep. And then they're not getting the phase 3 results. Okay. We've won, I think, 3 or 4 phase 2s, not that many. Sure. Okay. Our phase 2 on our combatant craft is about a $750 million impact across all these industries. That's the kind of stuff we want to see. And so in the new reauthorization, agencies are going to start restricting how many proposals companies can write, things like this. It was going to be much worse, and what came out of it, I think, came out really reasonable. And we're
just wanting to see more return on the, more return on the investment on that phase 3.
Yeah. Absolutely. Yeah. And that's it. Right. So, we learned about this project long before we bid it. And the first words out of my mouth to the Army Corps was, give us a phase 3. Let's get started now. And they were like, well, what are you talking about? And I go, Joni, tell them about phase 3. And they still like, well, what are you talking about? So the work we did with the Navy gives us unlimited sole source direct contract rights for anything related to or derived from our technology. Okay. That crosses agencies. it does not have to be in the Navy. I could go to Department of Health if I could sell them on an idea and get money if it's related to it. We can make tanks or something. And so the procurement system that we're stuck with a regular procurement sometimes take years to happen. They tie the innovators' hands, the government's hands, through these processes and systems. And the Canaveral Gate's a good example. It's a full up contract. You know, we had to bid the whole thing end to end, one big shot, push the button. Okay. Yeah. Now, had we been successful at doing a SIBR, we could have created phases, gates, stages, you know, things that couldn't be done very easily in the regular contracting cycle, but things we've learned through working with Department of Defense on how to mature technologies and how to reduce risk. Okay. But the good part is they heard part of it, you know, and we started to move the ball. We had a similar experience with the Army Corps on another project we'll talk about in a minute, saying, you know, they need engines and can't get the procurement system moving, or like, well, we have SIBR technology related to that. That frustration led to us helping push the reauthorization. And in the reauthorization bill, there's some really nice things that they've done. Okay, one of which is phase 3 is now much more prominent, and phase 3 contracting officers are going to get phase 3 training. They're going to be given templates for contracts, and there's going to be advocacy. So we're going to be able to see the return on investment the country's made in phase 1 and 2 in deployment. Okay. The other big thing they did is they've done something really creative. It's called the Strategic Breakthrough Award. Okay. And phase 1 is typically $250,000. Phase 2 is up to $2 million. This Strategic Breakthrough Award provides a second phase 2 up to $30 million.
Wow.
Okay. That's still in that SIBR pot of money. Yeah. Okay. It requires 100% match. 20% of that has to be Department of War, at least. Okay. So that means you need a customer who's committed to deploying the technology. And this is another really powerful tool they're bringing to help overcome what we call the valley of death between phase 2 and phase 3. Okay. And that's the valley of death. And it is pretty exciting to see. And, you know, we're really happy that we were able to influence it, and SIBR's up and running. It's reauthorized to 2032, I believe. Yeah. Is the date, with a lot of improvements. Okay.
Yeah, that, you know, that relationship with the Army Corps of Engineers, you know, we've had, you know, guests from IACME and ACMA, you know, talking about some of the joint training with the Army Corps of Engineers up in Ohio with is it Composite? What is it? Composites?
The Composites Institute, IACME.
Yeah. That's it. Drawing a blank for a second. Yeah. So, I mean, does a lot of that training, you know, kind of get more buy-in? I mean, I think that's just part of that relationship is really getting them on board and helping them understand, you know, how, you know, composites really are an advantage long term, but you have to get buy-in, right? So it starts with training their people and getting them understanding.
That's right.
Or giving them an understanding.
Right. So that's it. Right. So between, you know, you got a few associations. So ACMA, the Composites Manufacturing Association, plays a strong role in advocacy training. There's an infrastructure working group. That's good. And then over at IACME, the Composites Institute, you know, parallel to, you know, we've got working groups looking at a bunch of different areas. And you know, it's a combination of outreach, you know, educating the engineers to these new materials, because when you don't understand something, it's a black box, and getting them to understand it, getting them in a class, making a composite. And for us, there's nothing more fun than watching the metal guy become a composite.
So if a project like this succeeds as the way we expect it to, Joni, to your point earlier, I mean, this is a template, hopefully, for other applications, other projects like this moving forward. You know, flood barriers, bridge systems, offshore structures. I mean, you name it. That this really does open up the gate for other opportunities.
Yeah, there's quite a few in the pipeline that they exposed us to. So many of these structures, believe it or not, across the U.S. were built in the mid-'60s. So they're reaching their end and end of life.
Yeah.
And our composite materials are expected to last for 100 years.
100 years. Yeah, yeah. So, and I think you hit on something. I don't know if you saw the recent news. They're talking about potentially in the next 50 to 70 years, New Orleans might not be habitable anymore because the sea level increases.
Yeah, yeah.
So the whole waterway, flood protection, those areas you're hitting on right now are potentially going to become really important. If we start seeing that kind of shift of, instead of moving centimeters, sea level rise to inches, there's a lot of places in the country low lying that are going to be impacted. And I think composites have a big role in that.
Yeah.
Yeah.
Are you seeing, I think you kind of touched on it earlier, but an increase with this work with the Navy, the Army Corps of Engineers, an increasing demand from the Department of Defense for lighter materials, some of the composite applications. It's replace traditional. It looks like this is not only in infrastructure, but in other areas as well.
Yeah, no, that's great. It really is. And so if you kind of look now, the big, there's a lot of big things, but probably the biggest thing in the defense is small things. It's unmanned.
Yeah. Yep.
All right. So we're, you don't have to look far if you look at the conflict in Russia and to Ukraine to see where things are heading.
Yeah.
Right. So unmanned systems are everything. And so just to give you a feel, like over here, we provide, our same preforms that we're providing the boating industry, we provide Department of Defense.
Yeah.
And a significant part of our business is now unmanned watercraft, a very significant part.
Yeah.
And that's projected to triple next year, just within us. And then not to mention all the other places doing it. And so that's kind of our newest initiative, Jonathan, that we're really excited about. And through the prior civil work, right, we developed shock mitigating boats back in 2009. In 2012, we married those to emerging heavy fuel outboard engines that ran on jet fuel, Jet A or diesel fuel.
Sure.
We won a big award in 2016 that brought 4 different engine manufacturers in, Ox, Cox, Mercury, and Evinrude, to develop heavy fuel outboards along with our shock mitigating boats. As everybody might know, Mercury left the two-stroke market back in 19, leaving that platform the Navy couldn't get, and then we closed Evinrude in 2019. Through a silver Joni and I are doing now, we have a project making field assembled boats and kits. So we're trying to put them in containers. You got to build them on the beach. Of course, a boat isn't very good without an engine, and you can't use gasoline; it's too flammable. So I really was having trouble finding an engine. So I reached back into those contacts and network. And really happy to report in August of this year, we became the sole distributor for Evinrude outboards. So we're getting out of the materials box. And we have teamed with BRP, Evinrude, and we formed something called the Marine Defense Technical Network. And we're combining our material resources at Structural Composites with BRP's, not just propulsion, all their developmental resources.
Yeah.
So what we're trying to do is we're trying to provide bow to stern support for the OEM government boat community. This is not recreational boats. These are DoD boats, commercial boats. Yeah. And kind of what we're seeing is everybody is moving into unmanned across, all the primes. It's almost like you go to 7-Eleven, the guy behind the counter, I'm doing unmanned, and my unmanned's better than yours.
Yeah.
And so it's great that there's all this movement in software systems, sensors, but it doesn't make you a really good boat builder necessarily. Right. Okay. And so we're here to provide that platform support. And then the numbers are large compared to what we see in the government. Government buy of a boat might be 100 a year, regular boats. Now we're talking hundreds into thousands of these unmanned craft. Wow. So supply chains are going to be different. Manufacturing methods are going to be different. And I think really importantly, the structures have to be very, very different. Okay. Sure. Because the boats are going through loads that you'd never see in a manned platform. So it's a really exciting time for us.
Are a lot of these underwater craft, or
both? I think the surface craft is the big item right now.
Okay.
And
all right.
and interesting you mentioned that. We are moving into the underwater space. So we're one of 3 companies in the U.S. DNV certified for composites. We produce parts for Inkfish and Triton subs.
Yeah.
And we're just starting now. The Defense Department has kind of deemed the underwater space as the next frontier, and we're getting our first funding in deep sea composites. We've got some really cool tech that's coming up that we'll be able to show
I didn't
you.
know Triton made subs. I knew they made boats. I didn't know subs.
Triton subs. Yeah, it's a different company. Yeah.
Okay. I was gonna say, is that the same?
Yeah, you look them up. They're
Subs. Cool.
they're for billionaires. So
Yeah.
that's not.
Oh, of course.
I'm sure you can afford one. And then when you
Yeah.
buy the sub, you got to buy a ship to go with it to carry the subs. No
Yep.
big deal. But these go full ocean depth. You know, some
Okay.
the the full depth of the ocean, 18,000.
Yeah. So I mean, so that's got us, obviously survive some intense pressures down at that level. So
It is. It's
I mean,
a big
we actually had we had a guest shortly after the submersible disaster a few years ago.
Yep.
Talking about that, from a material standpoint. So yeah, that's well, that's pretty interesting. So are these these unmanned, both above water and even underneath? I mean, these are smaller craft.
The ones we're working on are, but that's not exclusive. Okay. So if you look, it's kind of, you can almost look to the transportation market and how it's going unmanned, so you got everything from a car all the way to a cyber trail, semi-trailer, something's happening at sea. All right. So there's a lot of effort now to create delivery systems, supply chains, other systems that are going to move stuff and keeping the man out of the mix.
Yeah, I mean that's the new the new military today is basically manless, drones, watercraft, everything.
It is, and
it's exciting though, in a sense from a from your standpoint in terms of technology and our industry specifically, because I think about it, some of these craft, or at least in the aerial applications. I don't know what the approval maybe gets done a little faster with unmanned vehicles than
you don't have the man rated requirements.
Right. Yeah.
No, that's it. That's exactly, you're hitting right on why it's good for guys like us. Okay.
Yep.
So
Absolutely.
in that project with the Air Force where we worked on the C-130, we were the floats, right, for the float plane. We got to benchmark ourselves against the aerospace guys in terms of our material performance and cost and weight. And so our marine composites, that the kind of things we're using here on the gates, we're about a 90% cost reduction from exquisite composites, the aerospace standard. And we weigh about 10 to 15% more. Okay.
Wow.
So it gives you a flavor. And so, when you're trying to make a lot of it go fast, attributable platforms, these kind of materials start to make a lot of sense.
This is exciting. Scott, it's been a pleasure having both you and Joni joining me today on the show. I want to highlight where people can learn more. You share your website, and we'll certainly feature that on the show page. Any other news before we wrap up that you'd like to share? And
it's really exciting, and for us, you'll see a couple divisions of structural composites. So SC Integrations is our company division that we're doing all the out of the box of composites, and come see us over at IBEX and CAMEX.
That's right.
They're out. We'll
IBEX coming up in what is that, October?
Yeah. And then for those in the boating community, the multi-agency craft conference is coming up mid-July, Portsmouth, Virginia. That's the government boat conference for those in the boating industry. You might want to come to see that.
Absolutely. And of course, you'll be at CAMEX in September.
Well,
all right, Scott, Joni, thank you both so much again. It's been a pleasure having you on. Thank you for your time today. Again, you can find them. You can find more about SCI by visiting structuralcomposites.com, and we'll have the link on our show page.